Bismillahirrahmanirrahim. Today we are going to discuss about the sample size calculation and test of statistical significance. I am Dr. Awais Gill and I am giving this presentation under the kind supervision of Professor Dr. Saira Afzal. The quote of the day is everything in the universe is within you. Ask all from yourself. The learning outlines of today's presentation will be what is sample size, important sample size, parameters regarding the sample size and its calculation in medical research, and the components of sample size calculation. By the end of this presentation, participants will be able to understand the significance of sample size and determine the sample size, understand factors that may affect sample size, and usage of sample size in research projects and tests of the statistical significance. Now, what is a sample size? Sample size is a term used in research for defining the number of subjects included in the sample size. It is a group of subjects that are selected from the general population and is considered a representative of the population for that specific study. As shown in the figure, this is the population and our sample is drawn from this population that is the truly representative of that population. No, if the sample size will be too big, it requires too much resources, and if that sample size is too small, we cannot do this job. Therefore, we have to choose the optimal sample size, which strikes a balance between the implications of making a type 1 or the type 2 error. Know what is alpha, confidence level, beta, power precision, and the degree of precision. No, alpha. Alpha is also called the level of significance. It is the probability of rejecting the null hypothesis when it is true. It is called the type 1 error, and the type 2 error is the beta. It is the probability of failing to reject the null hypothesis when it is false, for the probability for making a type 2 error. The confidence level is the probability that is an estimate of a population parameter within certain specified limits of the true value. It is commonly denoted by the 1 minus alpha, and the power is correctly rejecting the null hypothesis when it is false. It is denoted by 1 minus beta. No, if the null hypothesis is true and we reject it, it makes a type 1 error. And if the null hypothesis is false, but we do not reject it, then it makes a type 2 error. Now the margin of error. The margin of error is a statistic expressing the amount of random sampling error in a survey's results. Larger the margin of error, the less will be the confidence. Note sample size calculation in medical research. First, the investigator must specify the value for alpha, the likelihood that the null hypothesis will be rejected when in it is in fact true. By convention, it is usually taken to be 0.05 based on a two-tailed test of a statistical significance. Second, the investigator must specify a value for beta, the likelihood the null hypothesis is not rejected. It is usually set at 0.10 or 0.20. No, third, the investigator must specify the size of the effect of study is desired to be detected. For cohort studies with outcome measure defined as yes or no, the effect could be either a difference in relative rates or difference in outcome rates. For case control studies, the effect measure is usually an odds ratio. The smaller the effect size to be detected, the larger the sample size that will be needed. Finally, the investigator must provide an estimate of variance in measures of exposure or outcomes. Now, the requirements for sample size calculation is to calculate the optimal sample size for a test. We need to specify the following quantities at the design stage of the investigation. First, the power. The chance of detecting as actually significant a specified effect if it exists. We usually choose a power at least 80%. And the level of significance. The cutoff value below which we will reject the null hypothesis. For example, it is the maximum probability of incorrectly concluding that there is an effect. We usually fix this at 0.05 or occasionally at 0.01 and reject the null hypothesis if p-value is less than this value. Next is the variability. Number of observations per standard deviation. If we have numerical variable or proportion if we have a categorical variables. It is relatively simple to choose the power and significance level of the test that suit the requirements of our study. Given a particular clinical study, it is possible to specify the effect we regard as clinically important. The real difficulty lies in estimation of variance in numerical variable before we have collected data. We may be able to obtain this information from other published studies with similar outcomes. We may need to carry out a pilot study. In cross-section study, the aim is to estimate the prevalence of unknown parameters from the target population using a random sample. So an adequate sample size is needed to estimate the population prevalence with a good precision. The following simple formula will be used for calculating the adequate sample size in prevalence studies. That will be n is equal to z square into p into 1 minus p over d square, where z is the level of confidence, p is expected prevalence that can be obtained from the previous existing studies or can be calculated from the pilot study, while d is the precision. The level of confidence usually aimed for is 95%. Most researchers present their results within a 95% confidence interval. However, some researchers wants to be more confident and can choose a 99% confidence interval. It is needed to turn our confidence level into a z-score. Here the z-scores for the most common confidence levels are for 90% z-score is 1.645 and for 95% it is 1.96 and for 99% it is 2.576. But if we choose other than these values, we can found it from this z table. The value of expected prevalence. This can be estimated from the previous studies as already I told. Now, the estimation of precision. There is no kind of guideline for choosing the appropriate D. Some authors recommend to select a precision of 5% if the prevalence of the disease is going to be between 10 to 90%. Now, this is the formula. Uh, that is Z, and that is 1.96 if it is 95% confidence level. And this is the prevalence, that is the estimated prevalence. And this is 1 minus P, and then the D square. D is the precision. No, this is the example to clarify this equation. A researcher wants to carry out a descriptive study to understand the prevalence of proportions of diabetes mellitus among adults in the city. A previous study stated that the diabetes in the adult population was 40%. At 95% confidence interval and 5% margin of error, calculate the sample size required to conduct other new research. On applying, we put all these values in equation where z is at 95% confidence level is 1.96 96 and uh, p is equal to 40%, that is prevalence, and d precision is 5% or 0.04. On applying, if we put all these values in this equation, the sample size will be 369. No, in randomized controlled trials, sample size calculation methodology is like this. We can calculate sample size in number of ways. First, there is a general formula. These can be complex but may be necessary in some session. For example, to retain power in a cluster random type, we multiply the sample size that would be required if carrying out individual randomization by design effect equal to 1 plus m minus 1, where m is the average cluster size and r is the interclass correlation coefficient. And there are specific tests. These exist for different situations. For example, t-test, chi-square test for comparison of two survival curves, and the Altman's nomogram and the computer softwares. This is the Altman's nomogram. It is used. Altman nomogram is to estimate the sample size of two equally sized group of observations. In this, the left hand axis represents the calculated standard difference, and this right side tells us about the power, and the point of intersection with the diagonal line gives the sample size dependent upon the required level of significance, either 0.05 or 0.05. So therefore in this case at a significance level of 0.05, the required sample size will be around 70. Leher's formula. This is another formula for calculating the sample size. For the unpaired t-test and chi-square test, we can use this formula for calculating the sample size for a power of 80% and two-sided significance level of 0.05. This is its equation. N is equal to 16 over trie 2, where trie is the effect size. If we subtract from the power, sam sample mean from the other sample mean over sigma. Note that the numerator of 21 instead of 61 leads to power of 90%. Know the adjustments. There are two types that we needed adjustment. First is the loss to follow up, and other is the group of different sizes. To allow for losses to follow up by recruiting more patients into the study at the outset. If we believe that dropout rate will be R%, then the adjusted sample size obtained by multiplying the unadjusted sample size by 100 or over 100 minus r. And to have dependent group or different size, this may be desirable when one group is restricted in size, perhaps because disease is rare in case control study or because the novel drug treatment is short in supply. Now the sample size calculation formula. These are divided into two categories for studies trying to measure a variable with a certain precision, and the second is for studies seeking to demonstrate a significant difference between two groups. Now for the studies trying to measure a variable with a certain precision, these are the abbreviation where n is the sample size, s is standard deviation, e is required size of the standard error, r is the rate, and p is the percentage, and d is the confidence level. For single mean, its equation will be n is equal to s1 over e1, and for single rate, it will be n is equal to r over e1, and for single proportion, it will be n is equal to p into 1 minus p over e. These are the examples. Now the sample size calculation for two groups. The sample size calculation for two groups are dependent on different study designs. The sample size for any study depends upon acceptable level significance, power of study, expected effect size, underlying event rate in population, standard deviation population, and allowable error. For studies seeking to demonstrate a significant difference between two groups, we have these observations and these are the formulas. For the comparison of two means in each group, the formula is n is equal to u plus v into s1 plus s2 divided by m1 minus m2 into whole square. Now, sample size calculation experimental study. The main aim of sample size calculation is to find the number of participants needed to detect a clinical relevant treatment effect. Pre-study calculation of the required sample size is warranted in a majority of quantitative studies. Usually, the number of patients in a group are restricted because of ethical, cost, and time consideration. However, if the sample size is too small, one may not be able to detect any important existing event. Where too less sample size may waste time, resources, and money. Moreover, calculating sample size at design stage increasingly becoming a requirement when seeking ethical committee approval for research project. Now, this is the formula for the cross-section study, that is n is equal to p into q or into z over d into whole square. Now, the sample size calculation for two groups. The sample size calculation for two groups are dependent on different study designs. The sample size for any study depends upon acceptable level significant power study, expected effect size, underlying event rate in population, standard deviation population, and allowable error. This is the example. Now the now we come towards the test of statistical significance that we use in research. Now there we can divide them into parametric and non-parametric tests. If the distribution curve is normally distributed, then this will be the parametric test, and if the distribution curve is skewed, then it will be the non-parametric test. The parametric test, if the sample is 1, then it is a simple t-test, and its non-parametric counterpart will be the Wilcoxon test for one sample. And if there are dependent samples, it means that we are doing a research on a sample in which we do research on before and after. Then there will be paired sample t-test or the Wilcoxon test for the non-parametric test. And if there are two independent samples, let's say that we done research on two different samples, then it is called the independent sample. And the parametric test will be the unpaired sample t-test, while its non-parametric counterpart will be the man-Whitney U test. And if there are more than two independent samples, then the parametric test will be the 1 factorial ANOVA, and its non-parametric counterpart will be the full Well's test. And if there are more than two dependent samples, then we will use the repeated measures ANOVA and Friedman test. And if we have to establish the correlation between two variables, then we have Pearson correlation and Spearman's correlation. Now the paired sample t-test. This is the procedure uh, for demonstrating the how the t-test is performed. Testing the difference between the means or dependent samples. In step 1, we have to state the hypothesis and identify the claim. We state the null hypothesis and the alternative hypothesis. Null hypothesis said that there is no difference between the two groups of the samples of the paired samples. While the null hypothesis will state that there is a difference, it will be the two-tailed, or it says that the sample mean is lesser than the population mean, then it will be the left tail, and if it is greater than the population mean, then it will be the right tail test. Then in the second step, we have to find the critical values. Then we have to compute the test value. First, we have to make a table like this. We have first to put all the readings of the samples which are taken before, and then we have to put all the values uh, that we have taken later on. Then we have to find their difference, and then we have to sum all these values, and in the next step we have to take the square of all the sum of these values, and in the next step then we find the differences and place these are the explained. And in the next step then we find the standard deviation of the differences, and then we find the test value, and this is the formula for calculating the t, that is the difference in the t over mu d over by standard deviation into divided by n, where the degree of freedom is n minus 1. Then we make the decision whether to reject the null hypothesis or not the null hypothesis. If we the computed value is less than the critical value, then we reject the null hypothesis. Then we have to summarize the results. This is the test value. If the test value is observed value minus expected value over standard error. Observed value is the mean of the differences, while the expected value mu d is 0 if the hypothesis is mu d is equal to 0. Standard error of the difference is the standard deviation of the difference divided by the square root of the sample size. Know the Wilcoxon sign rank test. This is the non-parametric counterpart of the dependent sample t-test. In these, the steps are we state the hypothesis, identify the claim, and in the next step, we find the critical value from table K. Then we compute the test value. We make a table as shown in figure. It is most likely like the previous one. In this, we find the differences before and after and place the values in difference column. We find the absolute value of each difference and place the results in the value column. Then we rank each absolute value from lowest to highest and place the rankings in the right column. In this column, we rank each values from lowest to highest. If we rank the lowest value as 1 and the subsequent upper values as 2, 3, 4, and 5. Then then we give each rank a positive or negative sign according to the sign in the difference column. If there will be a positive and negative sign, then we find the sum of the positive ranks and the sum of the negative ranks separately. In the step 4, we make the decision whether to reject the null hypothesis if the test value is less than or equal to the critical values. Then we summarize the results. If the sample size is equal to or greater than the 30, we use table T and the test value. This is the sample. This is the formula where z is equal to ws minus n into n plus 1 over 4 divided by n into n plus 1 by 2n plus 1 over 24. No, these are the recent updates regarding the Wilcoxon sign rank test. The title of the article is The Effect of Health Education on Adolescent Knowledge About Anemia. The purpose of this study was to determine the effect of health education on the level of knowledge of adolescents about anemia. This research was conducted by providing health education to respondents about anemia. Before the health education was carried out, the researcher conducted the pretest to measure the respondents' level of knowledge. After the health education was carried out, the researcher conducted a post-test to evaluate the respondent level of knowledge about the anemia. The statistical test carried out in this study is Wilcoxon sign drag test with significant level of less than 0.05. The results of this study is stated is based on the data analysis using the Wilcoxon sign rank test. It was found that there was an effect of health education on the level of adolescent knowledge about anemia. And the conclusion is that it is important to provide health education about anemia to young women so that they can find out what conditions they experience when they are anemic due to menstruation. Health workers are expected to provide this health education through health counseling or education. Now, this is the another article whose title is Application of MRI in Diagnosis of Transient Dislocation of Patella. The objective of this study is to explore the diagnostic value of MRI in the transient dislocation of patella. The diagnostic radiology and MRI data of 35 patients with acute patellar transient dislocation from January 2015 to December 2017 were retrospectively analyzed, including 12 males and 23 females, ranging in age from 10 to 23 years old, with an average of 17 years old. The differences between diagnostic radiology and MRI diagnosis and surgical or discharge diagnosis were compared, and the differences between them in diagnosis of knee anatomical position, bone injury signs, and soft tissue injury were compared. The R statistical software will focus on sign and test was used for statistical analysis. All 35 MRI findings were completely consistent with the post-operative or discharge diagnosis. According to MRI, 7 cases of high patella and 7 cases of patella subluxation were diagnosed. According to diagnostic radiology, 7 cases of high patella and 0 cases of patella subluxation were diagnosed. 14 dislocations were diagnosed by MRI and 7 dislocations were diagnosed by diagnostic radiology. There was a statistical significant difference between the two methods in diagnosis of normal position of patella. Total 112 cases of bone injury were diagnosed by MRI and 0 was diagnosed by diagnostic radiology. There was statistical significant difference between the two methods in diagnosis of bone injury. Total 43 cases of soft tissue injuries were diagnosed by MRI and 0 was diagnosed by diagnostic radiology. There was statistical difference between the two methods in the diagnosis of soft tissue injuries. Total 35 cases of hydrops of the knee joint were diagnosed by MRI and 30 were diagnosed by DR. There was statistical significant difference between the two methods in the diagnosis of hydrops of the knee joint. The conclusion is that MRI is superior to diagnostic radiology in the diagnosis of acute temporal bone dislocation. MRI should be used as first choice for imaging diagnosis of acute temporal bone dislocation. It can avoid misdiagnosis and misdiagnosis. Now the time for the MCQs. Which of the following statements sounds like a null hypothesis? Whether the fine is not fair, there is a correlation in the population. There is no difference between the male and female incomes in population. Male income is more than the female, or the defendant is guilty.
C.
Null hypothesis is there is no difference between the male and female incomes, because in null hypothesis we say that there is no difference. This is the null hypothesis, so C will be the right option.
Charlie.
Second MCQ, a researcher finds that 70% of the students in sample have adopted a recommended practice of submitting the assignment with a precision rate of plus minus 5%. 5. Which of the following is not true about the level of precision? Whether it is the range in which the true value of population is estimated to be. It can be expressed as both percentage or points. Where third is the above scenario shows that 65% to 70% of the students have adopted the practice. The option in the above scenario shows that 70 to 75% of students have adopted the practice. Our precision implies the level of variation that lies in the values of several measurements of the same factor. We have to tell which is not true. It's 70 to 75%. Yes, D.
E.
Yes, D. Correct. Third MCQ, in case of testing the difference between means of two dependent samples, the degrees of freedom are equal to, whether we can calculate the degree of freedom by subtracting the n1 minus n2 total sample in one sample in minus second sample, or the n minus 1, or the t minus 1, or the smaller of the n1 minus 1, or the n2 minus 1, or larger of the n1 minus n1 minus 1, or n2 minus 1. Degree of freedom.
E.
B, yes, it's B. And if we subtract 1 from the total sample size, it will be the degree of freedom. Fourth MCQ is a group of 10 random students were randomly drawn from class 12 and was given yoga training for 3 weeks. Their wellness lifestyle was compared with another similarly selected group which did not undergo such training. Which type of statistical test will be appropriate if data were normally distributed for testing the tenability of null hypothesis? Whether dependent sample t-test, independent sample t-test, Wilcoxon sign rank test, Wilcoxon rank sum test, or chi-square test.
B. Delta. D.
It's alpha.
A.
Let me explain. As the sample is dependent, yoga training is done is given to the students, and then their wellness was compared before and after, and the data is normally distributed, so it will be a dependent. So we will apply the dependent sample t-test. If the data is normally distributed and the sample is dependent, then we use dependent sample t-test. So A will be the correct option. Fifth MCQ, as a researcher, you have been asked to determine if the air quality in Pakistan has changed over the past 2 years. You select a random sample of 10 metropolitan areas and find the number of days each year that the areas fail to meet the acceptable air quality standard. The data are shown. Find the degree of freedom for applying independent sample t-test, whether it's a 6, 7, 8, 9, or 10. We have to find that degree of freedom while using dependent sample t-test.
9.
Yes, 9. 10 minus 1. MCQ number 6. A study was done by Brody et al. In 2004 to know the difference between the brain volumes of smokers and non-smokers. The null hypothesis will be rejected if computed t-value is greater than the t-value, computed t-value is less than the critical t-value, computed t-value equals to critical t-value, computed t-value lies in the rejection region, or there is no difference between the means.
D.
Yes, it's B. We will reject the hypothesis if the computed t-value comes lesser than the critical t-value. Seventh MCQ, a researcher measured the same group of people's mood while watching horror films and compared them to when watching comedy films. The resulting data were normally distributed. What tests should be used to analyze the data? Whether dependent sample t-test, independent sample t-test, Wilcoxon sign rank, Wilcoxon rank sum, or the chi-square test.
Dependent sample t-test.
Yes, that's right. As the sample is the same, only they analyze their mood while watching horror and comedy films, and the data is normally distributed. So we will apply dependent sample. A study showed that surgeons who played video games for at least 3 hours each week made about 37% fewer mistakes and finished operations 27% faster than those who did not play video games. The type of surgery that they performed is laparoscopic surgery. The study uses means. What statistical test do you think that was used to compare the means if the data is skewed? Whether dependent sample t-test,
B.
independent sample, Wilcoxon sign rank, Wilcoxon rank sum, or chi-square?
Independent sample t-test. B.
Yes, it's independent. No, it will be the data is skewed, so it will
Q.
be Wilcoxon sign rank test. In dependent sample t-test or independent sample t-test, the data is not skewed. Ninth MCQ. In a large hospital, the medical superintendent wishes to see whether the number of fight incidents per day will change if the number of uniformed security officers is doubled. A sample of 7 days before security is increased and 7 days after the increase were collected. Which test will be best for hypothesis testing? Whether dependent sample test, independent sample test will focus on sign rank, Z-test, or ANOVA. Which will be dependent sample test. Last MCQ, 5 students take anatomy paper 1 in first year and anatomy paper 2 in second year. Their overall course grades in percentage are listed below for both courses. Which of the following statistical procedure would be the most appropriate to test the claim that the students' overall course grades are the same in both courses? Assume that any necessary normality requirements hold. these are the 5 students, and these are their percentage in first year, and these are their percentage in second year. And we have to answer between these 5 options whether two-tailed two-sample dependent t-test for means and two-tailed two-sample independent t-test for means. C option is two-tailed two-sample independent z-test for means. D option is one-tailed two-sample z-test for 4 questions. E option is two-tailed two-sample z-test for 4 questions.
A.
B.
Yes, it's a two-tailed
A.
two-sample t-test for mean. No, why it will be two tests? We have to prove that the mm, the grades remains the same. We do not have to establish whether their grades are greater than the first year or the first lesser than the first year. So we will apply the two-tailed dependent sample t-test. These are the key of the MCQs. This is our YouTube channel where all the presentations of postgraduate residents of community medicine in the King Edward Medical University are uploaded here. And thank you very much for today's presentation.
Thank you so much, Dr. West. Very nice presentation.
Thank you so much, Dr. West. Very nice presentation.
Okay, thank you very much.